Welcome back to the classroom. Today's topic is the study of sensors. This video is sponsored by Genreviews.online. Genreviews.online is one of the review portal site. A sensor is a device that generates an output signal to detect a physical phenomenon. In its broadest sense, a sensor is a device, module, machine, or subsystem that identifies events or changes in its surroundings and relays that information to other electronic systems, often a computer processor. Sensors are found in everyday items like touch-sensitive elevator buttons and lamps that adjust brightness with a touch on the base, as well as in countless applications that most people may not even notice. With advancements in micromachinery and user-friendly microcontroller platforms, the applications of sensors have grown beyond traditional areas such as temperature, pressure, and flow measurement, etc. Analog sensors, including potentiometers and force sensing resistors, remain widely utilized. Their applications span manufacturing, machinery, aviation, automotive, medical fields, robotics, and many other aspects of daily life. Additionally, there is a diverse array of other sensors that assess the chemical and physical properties of materials, such as optical sensors for measuring refractive index, vibrational sensors for determining flood viscosity, and electrochemical sensors for monitoring the levels of liquids. The sensitivity of a sensor refers to the degree of change in its output in response to changes in the input quantity it measures. For example, if the mercury in a thermometer rises by 1 centimeter when the temperature increases by 1 degree centigrade, the sensitivity is 1 centimeter per degree Celsius. Some sensors can influence the measurements they take. For instance, a thermometer placed in a hot cup of liquid will cool the liquid while the liquid warms the thermometer. Typically, sensors are designed to minimize their impact on what they measure. Reducing the size of the sensor often enhances this aspect and may provide additional benefits. Advancements in technology have enabled the production of more sensors at a microscopic level, known as microsensors, using MEMS technology. Generally, microsensors offer much quicker measurement time and greater sensitivity than larger scale methods. With a growing need for fast, cost effective, and reliable information in today's society, disposable sensors, affordable and user friendly devices for short term monitoring or one time measurements have become increasingly significant. These sensors allow anyone to obtain essential analytical information anywhere and anytime without the need for recalibration or concerns about contamination. Next is types of sensors. We live in a world filled with sensors which can be found in our homes, offices, cars, and more. These devices enhance our lives by performing tasks such as turning on lights when they detect our presence, adjusting room temperatures, detecting smoke or fire, brewing coffee, and automatically closing doors. In this section, we will explore various types of sensor in details. Number 1. Temperature sensors. These sensors monitor the temperature of devices used in industrial settings. They can measure the temperature of air, liquids, or solids and can be either analog or digital. An analog temperature sensor responds to temperature changes by altering a physical property such as resistance or voltage. A classic example is the LM35. A digital temperature sensor outputs a discrete digital value, with the DS1621 being an example that provides 9 bits of temperature data. Number 2. Accelerometer sensors. These sensors measure the rate of velocity change and provide data on magnitude and acceleration. The ADXL335 accelerometer sensor outputs analog voltage values for 3 axes like X, Y, and Z. These sensors are commonly used in automotive electronics, marine applications, and agricultural machinery. Number 3. Alcohol sensors. As the name implies, these sensors detect the presence of alcohol. They are typically found in breath analyzer devices, which assess whether an individual is under the influence of alcohol. Law enforcement officials often use breath analyzers to identify drivers who are operating vehicle while intoxicated. Number 4. Radiation sensors. Radiation sensors or detectors are electronic devices that identifies the presence of alpha, beta or gamma particles and send signals to counters and display units. They are utilized for conducting surveys and counting samples. Number 5. Position sensors. Position sensors are electronic devices designed to detect the positions of items such as valves, doors, and throttles, providing signals to control or display systems. Important specifications include the type of sensors, its function, measurement range, and specific features. These sensors are essential in various control applications where positional data is required. A common type of position sensor is the string potentiometer, often referred to as a string pot. Number 6. Gas sensors. These sensors measure and detect the concentration of various gases present in the atmosphere or other environments. Number 7. Torque sensors. Torque sensors are used to measure rotational torque and can also assess the speed of rotation. Number 8. Optical sensors. It also known as photosensors. These devices can detect light waves across different parts of the spectrum, including ultraviolet visible and infrared light. They are widely used in smartphones, robotics, and Blu-ray players. Number 9. Proximity sensors. These sensors detect the distance between two objects or the presence of an object. They are commonly found in elevators, parking facilities, vehicles, robotics, and many other environments. Number 10. Touch sensors. These devices identify physical contact on a designated surface. They are widely utilized in electronic gadgets to facilitate trackpad and touchscreen functionalities. Additionally, they are employed in various other systems including elevators, robotics, and soap dispensers. Number 11. Image sensors. These sensors are utilized for measuring distances, matching patterns, checking colors, structured lighting, and capturing motion. They find application in diverse fields such as 3D imaging, video and broadcasting, space exploration, security, automotive technology, biometrics, medical imaging, and machine vision. This is the brief study of sensors. Thank you for watching.